This video is about the definition of a function, and we'll do this in a couple different ways. First, verbally, we could say this. A function is a relation rule for inputs and outputs wherein every input has exactly one output. Exactly one is the key phrase in that verbal definition. And then there's some helpful notation that we'll get to that we can use to express these, but also conceptually, sometimes visually, it helps to say that there's an input and then some kind of input goes into this mysterious box known as the rule, and then out comes the output. Now there's some very common and important notation to discuss regarding functions, and here's a simple example of it. We could use the letter F to represent our function, and then we could follow that letter immediately by some parentheses containing, let's say, the letter X for now. Typically, parentheses are used in algebra or arithmetic to represent multiplication, but that's not the case in function notation. Here, it's an entirely different use. So we could say F parentheses X, close parentheses, equals, and then it could be equal to any number of things. I'm just going to make up an example here, such as x plus 2. Now, with this function notation, the letter that's in the parentheses right after the f, in this case, that x variable, when we said f parentheses x, that represents the input values that could be put into the function. Remember, the inputs turn into the rule. In this case, the rule is defined as x plus 2. And so the input is x, which could stay a variable or it could turn into a number. When you plug that value in for x in the rule, this rule says just add 2 to it. And then the result you get is what we would call the output. So the output will depend on the input and give you different answers for different inputs. Importantly, this little phrase f parentheses x is what we would say as f of x, not f times x. So again, the parentheses do not mean multiplication, they mean function notation. When we say f of x, of would say we're putting x as the input for this function expression. Let's now consider some examples that will help us understand the definition, the verbal definition we started with. These examples say, determine whether the table defines y as a function of x. There's a key phrase here when we say y as a function of x. It's telling us that the x is the input and the y is the output. And it's essential to know which is which to understand if something is representing a function or not based on the definition. In our first example, we contain a table with an x column and a y column, in other words, input and output columns. The x column down vertically reads 1, 2, 3, 4, and the y column down vertically reads 5, 7, 6, 8. We're wondering, does this meet the definition of a function we defined above? Well, our definition said that every input can have at most one output. So you can scan through this chart quickly to find that any given input, such as 1, 2, 3, or 4, is only mapping to one particular number on the output column. And so we could say, yes, this does meet the definition of a function. Now, if we look at example 2, the input column x reads 1, 1, 2, 3. The output column y reads 5, 7, 6, 8. But you may notice something interesting, which is that in the input column, the value 1 appears twice. Well, this is actually a problem because in the first row, 1 is mapping to 5. So when 1 is the input, 5 is the output. But in the second row, 1 is mapping to 7, meaning when 1 is the input, 7 is the output. But in this case, the input value of 1 has more than one output values. It has two different output values. This violates the definition, which means we'd have to say no, it's not a function. Let's further explore the definition of a function with the next examples, which read this: if f is a function, so we're assuming it is, are the following true or false? The first example states it is possible that f of 1 equals 5 and f of 2 equals 5. All right, so let's consider carefully and first of all recall the function notation. When I say f of x, we're referring to x as the input and whatever it's equal to as the output. Well, in this case, when we say f of 1 equals 5, that means when 1 is the input, 5 is the output. And then it says, secondly, f of 2 equals 5. Notice that 5 does repeat as the output, but that actually does not violate the definition because every input shown here, namely 1 and 2, each have one output. 1 goes to 5 and 2 goes to 5. That they both go to 5 is fine. The definition says nothing about a repeating output. So we could say confidently that number 3 is true. There's nothing wrong with that statement. And then number 4 says it is possible that f of 1 equals 5 and f of 1 equals 6. Well, as we can tell here immediately, the input value of 1 is repeating, f of 1 equals 5, f of 1 equals 6, but it's going to two different output values, 5 and 6. That's a problem because that means that the input value of 1 does not have one output, it has 2. So this would be false according to our definition. That's not a function.